Good morning. My name's Simon Martindale. Thanks very much for the investment of your time today. We're going to talk for the next 20 minutes or so about SIP trunking. More specifically, once we've done a general introduction, the different types of SIP trunk builds that are available. What are some of the considerations that you may have which may dictate a choice between the different types of build in terms of resilience for you. With the planned phase down of ISDN by 2025, everybody will be migrating away from physical phone lines to SIP trunking at some stage over the next few years. Obviously, ISDN operates over physical lines with the number of concurrent phone calls that you're able to make dictated by the number of channels that you operate with. With SIP, you move away from the physical world and into the virtual world, where every SIP call consumes an amount of bandwidth. We normally work around 100 KB a call. And obviously you need to ensure that you have adequate bandwidth available to deliver SIP calls securely and effectively. And there are a host of advantages that you may already be aware of migrating to SIP away from ISDN in terms of number flexibility, DR, which is what we're going to talk about today, number control and cost savings. So let's take a look at some of those advantages in a bit more detail. Okay, so over SIP trunking, as I say, there are a number of advantages over traditional ISDN. Firstly, in terms of number flexibility, it provides you with the option of presenting any geographical number out when you dial, regardless of the geographical area that you're based in. So if you need to present an Aberdeen number, for example, even though your staff is based in London, that becomes absolutely possible. Likewise, you're no longer committed to a fixed number of channels for a fixed period. So you have the option of scaling up and down capacity in line with seasonal demand. Classic case, for example, could be university clearing, where they have peaks and peaks in their demand during specific times of the year, and they scale up capacity to cope with that demand, but then they're able to avoid unnecessary costs by moving that capacity back down in quieter periods of time. SIP trunking costs less than ISDN, and therefore there are savings that are available to you through that migration program that you can use to facilitate other technology improvement projects such as mobility or other contact center call handling, that type of thing. If you operate with a networked infrastructure, you may be able to eliminate physical lines locally in offices and have all calls break out of one or two locations, and therefore by consolidating the number of lines across your group that you operate with, you can eliminate unnecessary local spend. Clearly you have number control, so rather than relying, for example, in an outage BT to divert all your numbers in a range to a specific location, which is a limit of number diverts when you operate with ISDN, over SIP you can divert individual numbers to individual locations as and when you want, supporting your DR program. Next, in terms of disaster recovery, there are some significant benefits, and that's what we're going to look at here through the course of the presentation across the differing types of SIP builds. We'll show you how, by choosing the correct SIP build for your environment, you can limit the risk of an outage and automate failover processes, whereby should there be infrastructure failure at any point of the legs that your calls operate over, your calls will automatically rehome to a diverse leg with no interruption in service. So let's take a quick look at before delving into the detail of the differing types of SIP build. We have standard, enhanced, active standby, load share, and resilient plus. So each of these builds will explain in a bit more detail as to how they work, in what scenarios we'd recommend them, and why you may consider them as you migrate to SIP trunking. Okay, the standard build. So the standard build, you'll have one endpoint. By endpoint we mean PBX, so or phone system. That'll be routing out over one connectivity link. Your packets will be taken out over one connectivity circuit to connect into the SIP carrier's core, and they'll take a single route through the SIP carrier's core using a single session border controller and pass your call out to the public telephone network. So clearly there are a number of single points of failure. It's this design that optimizes the savings that are available to you versus traditional ISDN. But clearly there are a number of single points of failure which you may want to consider and eliminate through the course of your SIP migration, and we'll explore those in a bit more detail to mitigate any risk of downtime um, through the course of your agreement. Okay, so the enhanced build, we think this is a great option for you because there's no commercial impact compared to the standard build. So you still optimize the savings that are available through the SIP endpoint. However, as you can see here, you still operate with a single instance of your phone system or PBX and a single connectivity pipe. But your packets, your voice calls, take two diverse routes through the SIP carrier's core network. What that means is, in the unlikely event that your chosen SIP carrier has an outage, an infrastructure outage, on the primary session border controller that delivers your phone calls, your calls automatically reroute to a second session border controller with no interruption in service and pass your calls out to the public telephone network. It's for this reason that the enhanced build becomes our default choice for those customers who haven't got the budget or cannot justify commercially a more complex, resilient build, but do want some of the peace of mind that resilience can provide. This is a good, cost-effective way of delivering on that objective. Okay, the active standby build. So in this scenario, as you can see here, we now have two instances of your phone system that act in active and passive mode, if you like. The active instance of the phone system, so this could be a physical instance or a virtual instance in a primary data center, acts as the primary means of delivering phone calls in and out. You also have a passive instance of the phone system that could be at a disaster recovery site, a data center, and that second instance of the phone system becomes active in the event of failure of any one of a series of legs through the SIP carrier's core. So once you pass the phone system, your primary phone system uses a connectivity circuit to deliver your SIP packets into the SIP carrier's network. Now, in the passive design, in the passive failover mode, should there be an outage detected either on the core infrastructure on the active site, the active connectivity circuit, or indeed the active session border controller within the SIP carrier's core network, then all your calls automatically rehome to your passive link and route through your second instance of the PBX, an alternative connectivity method, and then session border controller, and out to the public telephone network with no disruption in service. This is great because it protects against any single points of failure in the infrastructure design. It's not service impacting because your services automatically rehome to the passive link in the event of an outage. It does have some commercial impact because you pay a reduced fee for the passive trunks, if you like, the standby trunks, on a business as usual basis. So therefore, you are charged for them, albeit at a reduced rate, and they then become active in the event that there's an outage or in the event of a disaster recovery scenario. Okay, the active build. So in this case, you still have the two links, just as in the active standby mode. So you have two instances of the PBX, two connectivity pipes, and two routes through the SIP carrier's core network. Your DDI ranges will be split on a business as usual basis between your two endpoints, and those two endpoints are permanently active and carry alternate calls. So call 1 goes over link 1 and call 2 goes over link 2. You have equal capacity on each of the two links, so you may have 100 trunks on link A, which would allow 100 concurrent calls, and 100 links on link 2, which would allow 100 concurrent calls. However, in the event of an outage on the primary link, then only the secondary link remains active, and therefore you lose half of your capacity on a business as usual basis because you're relying on the second link to deliver your calls, albeit that you do have diversity in the design. Okay, so Resilient Plus is another level up from active, and the reason we think that this is a benefit is you still have two permanently active links, and you can decide on a business as usual basis which of the two links, if you have multiple DDI ranges, which of your DDI ranges reside on link 1 and which of your DDI ranges reside on link 2. Now the DDI ranges that only reside on link 1, their calls in business as usual pass over link 1, and the DDI ranges that reside on link 2 and business as usual pass over link 2. However, those DDI ranges migrate over onto this secondary link in the event of failure to their primary link or the link that they use on a business as usual basis. This is great because it allows you have the resiliency built into the design. You can split DDI ranges between endpoints. You don't have to match the SIP trunk capacity between the two endpoints. Um, Although if you do, it's excellent because you don't lose any capacity in a failover scenario and you can still operate in full capacity with no disruption of service. So we very much see this as the premium resilient design for those considering SIP trunking. Okay, finally, a great option to overlay over any one of the designs is a product called SIP Trunk Call Manager. So SIP Trunk Call Manager, irrespective of the resilient design of your SIP trunks, adds another level of flexibility at carrier level, if you like, so within the cloud, for want of a better word. And what SIP Trunk Call Manager allows you to do in the event of an outage is play things like auto greetings, automatic messages saying we're currently experiencing an outage to your customers, to change the way that your calls route on a business as usual basis, to gain and gather statistics on busy hours or when are your call volumes coming in. And most importantly as well, it also allows you to pre-build number divert, so a divert plan right down to DDI level. Save your pre-built DR plan as a template, and which you can then access either through a web browser or a mobile phone application. And then in the unlikely event that you are unable, you do lose service in a disaster recovery scenario, your building becomes unavailable, there's a power outage or circumstances beyond your control, then for those people who would like access, they're able to access um, through a web browser or through their mobile phone application and simply click Activate Pre-built DR Plan. By doing that, it automatically activates their pre-scheduled diverts, so their DR numbers. And so individuals, important individuals who have a DDI, for example, their pre-built DR plan may be map my DDI to my mobile number. They never suffer loss of calls in the event of infrastructure or power outage. So this is a fantastic way of overlaying functionality in the cloud to give you quick and easy control of your phone numbers, prevent against local infrastructure failure, and deliver on your business continuity plan.